Morning, everyone. Dr. Vaughn. I'm going to record a short video here about getting started in stats. And in particular, we're going to look at the homework from section 1.1 and 1.2 in MyStatLab. And if you haven't gotten over into that, look for the instruction document about how you click on the button, type in your registration code, and get registered into the system. As of this morning, I didn't see anybody in there yet, so I'm wondering if there might be a technical issue or if you just haven't got your access codes yet or what's going on. But anyway, watch for my other announcement about that. For this video, we're going to be concentrating on content specifically related to 1.1 and 1.2. I have 1.1 pulled up. Notice that your questions might be slightly different, in particular the numbers or the order of the questions. I've already done this question. You can see the little green check mark, and I thought that I would just get started with that, maybe do 2 or 3 from this homework problem, and then 2 or 3 from the homework 1.2. In this particular case, you have a midterm exam in a math class, and we're only trying to draw a conclusion about that math class, not about all math classes everywhere. And so what we have here is the population is just this math class, and we have the scores for all 50 students. So this average of 88 is describing the mean of the entire population. We're not making inferences about some bigger population. So because it's a population, we call it a parameter. And if it's a sample, we call it a statistic. So this is a parameter because we're talking about the population. And so that's the correct choice, parameter, because the data set is a population. Let me skip a couple more questions. Here's another one about qualitative or quantitative. Here's another one about whether this quantitative variable is discrete or continuous. Let's try that one. The number of bacteria seen on a microscope slide. The number of bacteria is going to be a discrete. It's either 3 bacteria or 4 bacteria. It can't be 2.73 bacteria. So this is countable. It might be a very large number, but it is countable, and therefore it's discrete. A. Now let's skip a little bit more, and we'll do maybe one more. This is all about levels of measurement. All right, and let's try this one. Level of measurement, highest degree conferred. High school, bachelor's, and so on. These are nominal. These are, naming of things, high school degree, bachelor's degree, so forth. You could make an argument for it being for it being ordinal because there is an ordering to them. But at the end of the day, this is just a qualitative variable, not a quantitative variable. And so I'm going to use nominal. Oh, and it looks like I got it wrong. They do actually want you to consider this as maybe you could translate this into a number, like high school is 12, bachelor is 16, and so forth. So then we're going to go with ordering. There is an ordering to them. I will have to say that you have to get used to the vocabulary for your particular book. There are some authors that would say that if it's not actually numeric, then you would not call it ordinal. But these ordinal ones are the ones that cross over. Nominal and ordinal cross over as qualitative or quantitative. Ratio and interval are definitely quantitative. Ordinal, some people will consider it only for quantitative variables, and some people will consider it for qualitative variables, which is why I got this wrong. Apologize for that, but I guess you've probably learned something in case you get a question like that. All right, let's maybe try one more. And this one looks like it has some data involved with it, but I think we're probably just interpreting this table of data that's actually given to you. So individuals, variables, and data. You notice that there's 2 parts. All right, so setup, that's a label, the size, the screen type, and the number of channels. So let's see, what are the individuals being studied? The individuals being studied here are high-definition televisions. And let's see, their screen sizes between 40 and 6 inches. That sounds correct. The televisions all have screen sizes between 40 and 60 inches. Let's see. High-definition televisions, setups A through E. I'm going to try that one. I think that one sounds better than this one, because these aren't just any televisions, they're high-definition televisions. And we do have screen sizes between 40 and 60, but maybe that's just because from this sample over here. I'm going to try these. All right, and then part B, what are the variables? Their size, and then the number of channels that are available. Screen type is a variable too. It's a qualitative variable, whereas these other ones are quantitative. So I think I'm going to go with B. Part A is really part of the descriptor. The size, the screen type, and the number of channels are the different variables. And is there a third part? Yes. Okay, so size is a quantitative continuous variable. All right, so size in inches, it could be 49.3 inches. It could be 49.372 inches. So I think that's a continuous variable. Screen type is qualitative because it's a category. And number of channels is definitely something that you're counting. You know, you have 5 channels or you have 6 channels. So this is a discrete variable. All right, those are my sample questions from your 1.1 homework. Hope that was helpful to you. Now we're going to exit out of this and we're going to go into homework 1.2. Okay, let's preview a few of the questions from that. Now we're going to look at whether it's an observational study or an experimental study and whether it's retrospective or not. I'm going to skip a couple of these. Observational study or an experiment. Right, 50 patients with lung cancer divided into 2 groups. One receives an experimental drug, the other a placebo. We're actually doing something by administering a drug to some of the people and not to the other. So when you're doing something, when the researcher is manipulating something, that's when it's an experiment as opposed to just kind of sitting back and observing. So this is an experiment because you control one variable to determine the effect on the other one. And let's skip a little bit more, maybe do one more. Observation, experiment, observation, experiment, observation, experiment. All right, let's see if we'll try maybe observation, experiment. All right, let's see if we can't go through this one. Okay, web page design has 2 designs on an online hardware store. To determine which is the more effective design, the firm uses one page on a mobile platform and a second one on a desktop. And they're going to record the amount of time spent by the visitor and the amount of time visiting the site. All right, so let's see, the explanatory variable and the response variable. So the explanatory variable is going to be whether they're using the mobile platform or the desktop. And then the response variable is the amount of time and the spent visiting the site. All right, so the explanatory variable is the viewing device and it's qualitative. Let's see, maybe I got that wrong. Oh, maybe I just got them backwards. The explanatory variable is the amount of time spent visiting the site, and it's quantitative. Okay, well, I had it right the first time, but they just call it not the viewing device, but the web page design. So I suppose that the mobile platform versus desktop is the website design, not a viewing device. Okay, then. I'm not sure I completely understand that, but as you can see, I'm human. I make mistakes as well. And so, again, the nice thing about working in MyStatLab is that you get these multiple attempts. I'll show you that. So when we get done with all of this question, okay, I got that part wrong. It marked it wrong. It shows me what the correct answer is. Now I'm going to go on to the next question. What are the 2 response variables? Okay, the response variables are going to be the amount of time visiting the site. Okay, and then that's quantitative, and then the amount spent by the visitor, and that's also quantitative. All right, so now, oh, there's a third part, how confounding might be an issue with this study. So confounding is where there's another variable that might actually be, controlling what's on, and there might be interaction between them. That interaction is not really the confounding. The there might be confounding is when there's something else that might be kind of controlling your preferences depending upon the viewing device. And since there's only one, okay, I think that this is the only one that really points to confounding as opposed to interaction. All right, so anyway, now I've completed this question. I got the first part wrong. I learned from that. So now you can come down here and say, show me a similar question. And it'll actually generate a whole new kind of determination. It's actually the same one in this case. And now I can go back and actually get it right this time. Okay, so this time the explanatory variable is the web page design. Okay, that seems the right answer. And now, which the two response variables? That's the number of items viewed. Okay, they did kind of change things. The rating on the layout and the number of items viewed. Number of items viewed and the rating on the layout. And then we'll go on to the last one, confounding. Okay, that's not that one. Interaction. Okay, preferences. That one seems like the confounding answer. And now I actually got it right. And it updated my score. If you look at your overall homework progress, now I have the full green check mark instead of part of it right and part of it wrong. So, okay, I hope this has been helpful, getting off to a good start in MyStatLab, using the question help, learning from your mistakes, and redoing questions, similar questions, to get the best possible score on your homework. Hope you have a great day, and I'll try to give you some additional videos like this throughout the week. I also hope that if you're available, you can join me on Zoom. Look for the announcement in the class.